Now that the preparations are complete, it's time to get started on the workpiece. Typically, before starting the milling operation, a vise is mounted on the machine bed by means of clamps. In order for the workpiece to be cut correctly, the vise must be absolutely straight. You will first need to align the fixed jaw of the vise with respect to the X or Z axis of the milling machine. Temporarily fix the workpiece between the vise jaws. Bring the workpiece in line with the spindle and remove it. By using a dial gauge, you can get a vise to be perfectly straight. Lower the machine bed using the table handle, leaving the bottom of the spindle about 1 foot above the vise. Attach the dial gauge holder to the spindle. Adjust it so the dial gauge feeler touches the fixed jaw of the vise. Move the vise along the X-axis, allowing dial gauge feeler to press against the fixed jaw. You will see the dial gauge needle move, indicating that the tip is touching the jaw. Rotate the bezel of the dial gauge to bring the zero of the dial in line with the needle position. This will give you a reference point for the indicating process. Move the vise, you will notice that the needle jumps around, indicating disalignment. Ideally, the needle should stay at 0, the entire length of the fixed jaw. That way you know it is aligned perfectly. Gently tap the vise on the sides using a copper hammer until you get a solid 0 reading across the jaw. Continue tapping till the dial gauge reading is within the permissible tolerance limit across the fixed jaw of the vise. Use a ring spanner to tighten the vise on this position. Once you have secured the vise, recheck the straightness of the vise. Ensure it is 0 across the length after you have tightened the vise. Do the final tightening of the bolts. Remove the dial indicator. Next, clamp the workpiece in the milling vise. Before you lay down the workpiece, you must clear off the burrs and any debris build-up. Remember, any residual burrs can affect the precision of your cut. Position the workpiece between the jaws of the vise. Go on to secure the workpiece. Use a vise handle to tighten the vise jaws. Use a copper hammer to tap the piece in position. Move on to mount the required cutter in the spindle. As per the sequence of operation, here the operator has appended the surface and face milling cutter in the spindle. Once the cutter is in position, raise the workpiece, bringing it in line with the cutter. Before you touch the workpiece to the cutter, you must ensure the cutter is in revolving mode. Bring the workpiece in contact with the tip cutter. Advance the workpiece past the cutter to take a skin cut. Perform the 0 setting on the Y-axis dial. Give a minor depth of cut and move the workpiece past the cutter and remove the required layer of material. As you will remember, each axis has its own dial. Use them to make appropriate dimensional cuts. This flat machine surface will act as a reference for the ensuing cuts. Remove the workpiece. Clear the burrs from the workpiece and clean the vise properly. Put the machine surface of the workpiece down and clamp the workpiece. Power on the mill and machine the surface to cut the workpiece to the desired shape and dimensions. Use ample coolant to keep the tip of the cutter cool during the cutting process. Once the workpiece has been machined to the appropriate size, remove it. Deburr the edges of the machined surface using a flat file. Clean the vise. If required, use the packing to raise the level. Clean the packing before you set it. This adequate clearance will allow the cutter to perform the operation without any obstruction. Once you have cleaned the workpiece, rest it on top of the packing. Gently tap the workpiece to secure it. Check to see if the packing is secure. Tap the workpiece again to set the packing in place. Once you have made the necessary adjustments, tighten the vise jaws. Treat the surface milling cutter with an end mill cutter. Insert the collet into the spindle hole. Next, go on to adjust the speed. Change the revolutions per minute accordingly. Bring the pulleys closer and place the belt in the required groove of the pulleys. Tighten the belt by moving the pulleys apart. Move the workpiece and take a skin touch. Remember, before you start cutting, you must always check to see if the cutter is in the revolving mode. Perform the facing operation to clean the surface. Remove the workpiece and deburr the machined side. Rest the workpiece to clean the other side of the workpiece. Perform the facing operation, bringing the workpiece to the requisite size. Measure the workpiece using a vernier caliper. Swap the end mill cutter with the surface milling cutter. Change the RPM accordingly. Take a skin touch and perform the zero setting on the Y-axis dial. Proceed with the surface milling operation. Remove the metal chip using the brush. Clean the vise and the workpiece. Remove the burrs on the machine surface using a flat file. Replace the surface milling cutter with an end mill cutter. Start the step cutting operation. Take a skin touch and perform the zero setting on the Y-axis dial. Give a small depth cuts by moving the workpiece along the Z-axis. Similarly, make the subsequent cuts by shifting the workpiece. Continue to clean the surface in between using the brush. Make the second step cut along the width of the workpiece in the same go. Proceed to cut the second step along the length of the workpiece. Once you have cut the required steps, clean the surface using a brush. Moving on, prepare for the slot cutting operation. In order to ensure cut accuracy, you must perform the zero setting on both the X and Y axis dial. Typically, you would take a skin cut, but in this case, that technique would render the workpiece useless. Here is a simple trick to do this without actually taking a skin cut. Mount a steel rod of the same diameter as that of the end mill cutter in the spindle. Paint the workpiece face with a special marking dye. Advance the workpiece, bringing it in contact with the revolving steel rod. Notice, the rod will make a very fine vertical mark on the colored surface. This slight edge will ensure that the steel rod has touched the workpiece and you can go about setting the X-axis dial to 0. Proceed by switching the steel rod with an end mill cutter. Make the incision using the dial readings on both the X and Y axis dial, while moving the workpiece along the Z axis. Clean the surface with the brush. Measure the width of the slot using the inside jaws of the vernier caliper. Apply the same trick to get the accurate coordinates for boring the hole. Use the rod to perform the zero setting on both the X and Z axis dial. Trade the rod with the center drill and make a pilot hole. Change the center drill with a twist drill. Make sure to use a twist drill of diameter slightly larger than the minimum diameter of the boring tool. Give a small depth cut with the twist drill and cross-check the center of the hole with respect to the coordinates. Continue the drilling operation. Next, you will need to ream a perfect hole. Use a reamer to enlarge the pre-drilled hole to the precise diameter. Next, perform the chamfering operation along the various edges of the workpiece. Remove the workpiece and deburr the machined surface. Deattach the vise from the machine. Use a ring spanner to loosen the bolts. Clean the table and mount the rotary vise. Using the ring spanner, fasten the rotary vise onto the machine bed. Clamp the workpiece onto the rotary table with the help of T-head bolts and clamps. Match the height of the workpiece step to that of the clamp support and tighten using a nut. Before you start the milling operation, you must align the center of the rotary vise with the center of the machining press. This is where the reamed hole comes into play. Insert the reference rod into the reamed hole without applying any additional force. Mount the dial gauge onto the spindle. Bring the dial gauge feeler to touch the reference rod. Watch the dial gauge needle for variation while rotating the workpiece. You must ensure that the feeler does not lose contact with the reference rod. Use a copper hammer to adjust the alignment. Make the necessary adjustments using the copper hammer to tap the workpiece in place. Once you have made the necessary adjustments, tighten the clamp support and remove the reference rod. Replace the dial gauge to ensure alignment of the length of the workpiece with respect to the Z-axis. Bring the workpiece parallel to the Z-axis by moving the indexing arm. Mark a point or hole on the indexing wheel. This will act as the zero position. The indexing wheel helps you calculate the degrees of the circular motion, allowing you to make accurate repeated cuts. Load the twist drill onto the spindle. Perform the drilling operation to facilitate the boring operation. Swap the twist drill with the boring tool. Slip the boring tool into a holder and mount it onto the spindle. The boring tool holder has an adjustable dial on its head. This allows you to vary the diameter of the bored hole. This particular boring hole has the least count of 0.02 millimeters. Simply said, it will remove the diameter of twice that amount in one go. Perform the zero setting on the boring tool dial. Execute the boring operation to achieve the required bored dimensions. Perform the chamfering operation along the edges of the bored hole. Moving on to the contour milling operation. Swap the boring tool with an end mill cutter for this task. Perform the zero setting of the Y-axis dial. Make an apt cut. Gradually increase the cut along the Z-axis. Oscillate the rotary table while the cutting tool is actively removing the material. Change the end mill cutter, replacing it with a chamfering tool. Perform the chamfering on the contoured edge. Remove the workpiece using the ring spanner to loosen the nuts holding the clamping support. This is what the finished product looks like. Use this practical guide to lead you through the complete process of machining a component on a milling machine. Here is a recap of the broad steps you need to perform to complete the component. Step 1. Set and align the vise. Step 2. Set the workpiece. Step 3. Load the cutter in the spindle. Step 4. Perform the surface milling operation. Step 5. Perform the face milling operation. Step 6. Perform the step cutting operation. Step 7. Perform the surface milling operation. Step 8. Perform the slot cutting operation. Step 9. Perform the drilling operation. Step 10. Perform the reaming operation. Step 11. Perform the chamfering operation. Step 12. Mount and align the rotary vise. Step 13. Perform the drilling operation. Step 14. Perform the boring operation. Step 15. Perform the chamfering operation. Step 16. Perform the contour milling operation. Step 17. Perform the chamfering operation. Step 18. Remove the workpiece.